National requirements often drive extreme aircraft characteristics. The U-2 overflew Moscow and was seen on radar, and pictures showed surface-to-air missiles being deployed. President Eisenhower directed that a new aircraft be created, not flying at 450 miles an hour, but 2,150, not at 70,000 feet, but at 85,000 feet, and would be America's first stealthy airplane. When you're flying an airplane at Mach 3, the surface temperature will exceed 600 degrees. The airplane will grow 3 to 4 inches in length, an inch or two in width. Aluminum can't be used, so 93% of the aircraft is made of titanium. Special fuels had to be created, JP7, to withstand the high temperatures. Normal fuel has a flash point of minus 40 degrees. JP7 is a plus 335. Electric ignition would not work, so the chemical triethylene borane, which explodes at 3,000 degrees, is used to start the engine and to light the afterburners. Stealthy airplanes, by their nature, are unstable. So on the pedostatic in the front of the airplane, there's a side probe. It has a hole on the top and the bottom on either side. It's measuring the airflow to see if there's divergence in the yaw and the pitch, and it is putting in slow inputs to keep the aircraft under control. When you're traveling at 35 miles a minute, navigation is a real challenge. This is the first airplane that had an automated star tracker. We guaranteed the president 300 feet anywhere in the world traveling at 2,200 miles an hour. The real genius of the airplane is the integration of the inlet, the engine, the bypass tubes, and the afterburner. This combination would allow you to cruise at 3.2 Mach. And the best way to depict it is to start you on the ground and take you through a climb profile. You've started the engines, you've taxied, you're on the runway, you release the brakes, you light the afterburners. In 20 seconds, you will have gone over 4,500 feet. You're lifting off doing 210 miles an hour, and you're going to cross through 20,000 feet in less than 2 minutes from the time you release the brakes. To get through the high drag area with this airplane, we would climb to about 33,000 feet at 0.9 Mach, lower the nose, go to maximum burner, and accelerate through 1.1 Mach, the high drag regime, and then start the climb again. Around 1.7 Mach, the spikes would unlock and we'd make sure that they were moving aft. The spikes were absolutely critical to keeping the shock wave inside the inlet and to allow for the compression, which sets up the ram effect. At 1.8 to Mach 2, the inlet guide vanes, which up until this point had been straight ahead to let all the air in, would turn to a camber. The excess air would now be picked up by the aft bypass tubes, which goes around the engine, which is 2,000 degrees, directly into the afterburner, which is 3,400 degrees, which needs additional air for cooling, and you also get additional thrust. This is the only airplane that I'm aware of in the world. The faster we went, the less fuel we burned. Our normal cruise speeds were Mach 2.8, 3.0, 3.15, or 3.2. On your first mission in this airplane was subsonic. We took you up to a tanker to learn to refuel and then practice landings. Tankers were absolutely vital to us because every 2 hours we had to come down from altitude and either refuel or land after we had traveled over 3,000 miles. This absolutely remarkable airplane is still ahead of its time. The absolute speed record still stands of 2,193 miles an hour, set in 1976.